According to the 2020 National Electrical Code, all new ceiling fan installations must be protected by an arc fault circuit interrupter, or AFCI. This requirement stems from the potential fire hazards associated with ceiling fans. Firstly, motor starting currents can create arcing. When a ceiling fan motor starts, it draws a large amount of current, which can, under certain conditions, lead to the formation of electrical arcs. Secondly, dust and debris accumulation on the motor and fan blades can create a fire hazard when exposed to an electrical spark. Over time, dust and debris can build up on the fan's components. This accumulation, when combined with an electrical arc, can ignite, leading to a fire. Thirdly, the movement of the fan blades can generate static electricity, which can also lead to arcing. The rotation of the blades can produce static electricity, which, if discharged improperly, can create an arc. AFCI devices are specifically designed to detect and interrupt these hazardous electrical arcs that can cause fires. These devices monitor the electrical circuit for abnormal arc patterns. When a dangerous arc is detected, the AFCI will quickly trip the circuit, cutting off the power and preventing a fire from starting. Therefore, the installation on ceiling fan circuits is essential for electrical safety. To understand the AFCI protection requirement fully, it's helpful to delve into the details of arc faults and AFCI devices. An arc fault is an unintentional electrical discharge between two or more conductors. These arcs generate intense heat, which can ignite nearby materials, leading to a fire. There are two main types of arc faults: series arc faults and parallel arc faults. Series arc faults occur when there is a break in a single conductor. For example, a loose connection in a wire can create a series arc fault. Parallel arc faults occur when there is a short circuit between two conductors. For example, damaged insulation on wires can create a parallel arc fault. AFCI devices are designed to detect both series and parallel arc faults. They use sophisticated electronics to analyze the current and voltage waveforms in the circuit. When an arc fault is detected, the AFCI device quickly trips the circuit breaker, cutting off the power and preventing a fire. There are two main types of AFCI devices: branch circuit AFCI breakers and outlet branch circuit AFCI receptacles. Branch circuit AFCI breakers are installed in the electrical panel and provide arc fault protection for the entire circuit. Outlet branch circuit AFCI receptacles are installed at the outlet and provide arc fault protection only for that outlet and any downstream outlets on the same circuit. The NEC requires that all new ceiling fan installations be protected by a branch circuit AFCI breaker. This provides the most comprehensive arc fault protection for the entire circuit. When installing an AFCI breaker, it's important to follow the manufacturer's instructions carefully. The breaker should be installed by a qualified electrician to ensure that it is properly wired and functioning correctly. After the AFCI breaker is installed, it should be tested to verify that it is working properly. This can be done by pressing the test button on the breaker. When the test button is pressed, the breaker should trip, indicating that it is functioning correctly. If the breaker does not trip when the test button is pressed, it should be replaced immediately. In addition to installing AFCI protection for new ceiling fan installations, it's also important to take other steps to prevent electrical fires. Firstly, regularly inspect electrical cords and plugs for damage. Damaged cords and plugs can create a fire hazard. Secondly, avoid overloading electrical outlets. Overloading an outlet can cause it to overheat and start a fire. Thirdly, keep flammable materials away from electrical outlets and appliances. Flammable materials can easily ignite if they come into contact with a spark or heat from an electrical outlet or appliance. Fourthly, have your electrical system inspected by a qualified electrician on a regular basis. An electrician can identify potential electrical hazards and make recommendations for repairs or upgrades. By taking these steps, it is possible to reduce the risk of electrical fires and keep our homes safe. Furthermore, it is important to understand the specific requirements of the 2020 National Electrical Code regarding AFCI protection for ceiling fans. The NEC is a set of standards for electrical wiring and equipment in the United States. It is updated every 3 years to reflect the latest advances in electrical safety technology. The 2020 NEC contains several provisions related to AFCI protection for ceiling fans. Firstly, Section 210.12 requires that all 120-volt, single-phase, 15 and 20 amps branch circuits supplying outlets or devices installed in dwelling units be protected by an AFCI. This includes circuits that supply ceiling fans. Secondly, Section 210.12 provides an exception to the AFCI requirement for certain circuits that supply smoke alarms or carbon monoxide alarms. However, this exception does not apply to circuits that supply ceiling fans. Thirdly, Section 422.16 (1) requires that ceiling fans be supported by outlet boxes that are listed for the purpose. This ensures that the ceiling fan is securely mounted and that the electrical connections are properly protected. Fourthly, Section 422.31 requires that ceiling fans be installed in accordance with the manufacturer's instructions. This ensures that the fan is properly wired and that it is safe to operate. In addition to the NEC requirements, there may also be local built-in codes that apply to ceiling fan installations. It is important to check with the local building department to determine the specific requirements in a particular area. When selecting an AFCI breaker for a ceiling fan circuit, it is important to choose a breaker that is rated for the appropriate amperage. The amperage rating of the breaker should match the amperage rating of the circuit wiring. It is also important to choose a breaker that is listed by a recognized testing laboratory such as Underwriters Laboratories or UL. This ensures that the breaker has been tested and certified to meet safety standards. When installing an AFCI breaker, it is important to follow the manufacturer's instructions carefully. The breaker should be installed by a qualified electrician to ensure that it is properly wired and functioning correctly. After the AFCI breaker is installed, it should be tested to verify that it is working properly. This can be done by pressing the test button on the breaker. When the test button is pressed, the breaker should trip, indicating that it is functioning correctly. If the breaker does not trip when the test button is pressed, it should be replaced immediately. In addition to installing AFCI protection, it is also important to properly maintain ceiling fans to prevent electrical fires. Firstly, regularly clean the fan blades and motor housing to remove dust and debris. Dust and debris can accumulate on the fan's components and create a fire hazard. Secondly, check the fan blades for cracks or damage. Damaged fan blades can create a vibration that can loosen electrical connections. Thirdly, tighten any loose screws or bolts on the fan. Loose screws and bolts can create a fire hazard. Fourthly, have the fan inspected by a qualified electrician on a regular basis. An electrician can identify potential electrical hazards and make recommendations for repairs or upgrades. By taking these steps, it is possible to reduce the risk of electrical fires and keep a home safe. In summary, the 2020 National Electrical Code requires that all new ceiling fan installations be protected by an arc fault circuit interrupter, or AFCI. This requirement stems from the potential fire hazards associated with ceiling fans. AFCI devices are designed to detect and interrupt hazardous electrical arcs that can cause fires. Therefore, their installation on ceiling fan circuits is essential for electrical safety. When installing an AFCI breaker, it is important to follow the manufacturer's instructions carefully. The breaker should be installed by a qualified electrician to ensure that it is properly wired and functioning correctly. After the AFCI breaker is installed, it should be tested to verify that it is working properly. By taking these steps, it is possible to reduce the risk of electrical fires and keep a home safe. Moreover, understanding the rationale behind the AFCI requirement for ceiling fans is crucial for appreciating its importance. As previously mentioned, ceiling fans present several potential ignition sources. Motor starting currents, dust accumulation, and static electricity generation can all contribute to the risk of electrical arcs. These arcs, if left undetected, can quickly escalate into a fire. The implementation of AFCI protection acts as a safeguard against these risks. By continuously monitoring the electrical circuit, the AFCI device can identify and interrupt even the smallest arcs before they have a chance to ignite surrounding materials. This proactive approach significantly reduces the likelihood of electrical fires caused by ceiling fans. Furthermore, it's important to recognize that the AFCI requirement is not limited to new ceiling fan installations. The NEC also mandates AFCI protection for other types of electrical circuits in dwelling units, such as those supplying outlets in bedrooms, living rooms, and dining rooms. This comprehensive approach to arc fault protection reflects the widespread recognition of the potential fire hazards associated with electrical arcs. By implementing AFCI protection throughout a home, it is possible to create a safer living environment for everyone. In addition to the safety benefits, AFCI protection can also offer other advantages. For example, AFCI devices can help to protect sensitive electronic equipment from damage caused by electrical surges. The electrical surges can occur due to lightning strikes, power outages, or other disturbances in the electrical grid. These surges can damage or destroy electronic equipment such as computers, televisions, and stereos. AFCI devices can detect these surges and quickly interrupt the circuit, protecting the equipment from damage. Moreover, AFCI protection can help to reduce the risk of nuisance tripping. Nuisance tripping occurs when a circuit breaker trips unnecessarily, interrupting power to the circuit. This can be caused by a variety of factors, such as electrical noise, faulty appliances, or loose wiring. AFCI devices are designed to be less susceptible to nuisance tripping than traditional circuit breakers. This is because AFCI devices use sophisticated electronics to distinguish between harmless electrical noise and dangerous arc faults. By reducing the risk of nuisance tripping, AFCI protection can help to ensure that electrical circuits remain operational and reliable. In conclusion, the AFCI requirement for new ceiling fan installations is a critical safety measure that helps to prevent electrical fires. By understanding the rationale behind this requirement and taking steps to ensure that AFCI protection is properly installed and maintained, homeowners can create a safer living environment for themselves and their families. The benefits of AFCI protection extend beyond fire prevention, including protection against electrical surges and reduction of nuisance tripping. By embracing this technology, homeowners can enhance the safety and reliability of their electrical systems. It's also beneficial to consider the long-term implications of installing AFCI protection. While the initial cost of AFCI breakers may be slightly higher than traditional circuit breakers, the long-term benefits in terms of safety and potential cost savings from preventing electrical fires far outweigh the initial investment. Furthermore, AFCI protection can increase the value of a home. Many home buyers are now aware of the importance of electrical safety and are willing to pay a premium for homes that are equipped with AFCI protection. By installing AFCI protection, homeowners can not only protect their families and property, but also increase the value of their investment. In addition to the practical benefits of AFCI protection, it's also important to consider the ethical implications. As responsible members of society, we have a moral obligation to protect ourselves and others from harm. By installing AFCI protection, we are taking a proactive step to prevent electrical fires and protect our families, neighbors, and communities. In the event of an electrical fire, the consequences can be devastating. Lives can be lost, property can be destroyed, and families can be displaced. By taking the simple step of installing AFCI protection, we can help to prevent these tragedies from occurring. It's also important to remember that electrical safety is not just the responsibility of homeowners. Landlords, building managers, and contractors also have a responsibility to ensure that electrical systems are safe and up to code. By working together, we can create a safer electrical environment for everyone. In summary, the AFCI requirement for new ceiling fan installations is a vital safety measure that should be taken seriously. By understanding the rationale behind this requirement, installing AFCI protection properly, and maintaining electrical systems regularly, we can all contribute to a safer and more secure future. The benefits of AFCI protection extend beyond fire prevention, including protection against electrical surges, reduction of nuisance tripping, increased home value, and ethical considerations. By embracing this technology, we can create a world where electrical fires are a thing of the past. Always consult with a qualified electrician for any electrical work to ensure safety and compliance with local codes.